Hello everyone, in this video we're going to talk about complex fractions. So I'll give you an example. So if we have something like this, x over x plus 1 minus b over b plus 1 divided by, this whole thing divided by b minus x. So how would we start? So the first thing we need to do, so this problem calls for simplification. Okay, so we need to achieve a single fraction in which the numerator will not be a fraction but will rather be an expression involving a few terms. Okay, so first we must do something with the numerator, right? We have to use the LCD property in order to eliminate these two fractions and achieve their difference and combine it into a single fraction. So what's the LCD? The LCD of x plus 1 and b plus 1 is simply their product. X plus 1 times b plus 1 will be the least common denominator. So we have to multiply this fraction by x plus 1 over x plus 1, right? Not violating the fundamental principle of fractions. So we will have x over x plus 1 multiplied to b plus 1 over b plus 1, and then minus b over b plus 1, and this fraction will be multiplied by x plus 1 over x plus 1, right? Because we need to achieve the LCD. So x plus 1 over x plus 1, and this whole thing divided by b minus x, and then we will simply have xb plus x. We're going to distribute the small numerators of the top fractions minus bx minus b, right? Because we're going to distribute the minus to both of these terms, and then over x plus 1 and times b plus 1, and this whole thing again divided by b minus x. Okay, so now these two guys will go away, right? So we will have x minus b divided by x plus 1 and b plus 1, and now we're going to divide it by b minus x, and we're going to have this division sign expressed like that. And then simply we can use the property of subtraction division by flipping the fraction to the right of the division sign. Okay, so let's have x plus 1, keep that, b plus 1, multiplied. So this b minus x is expressed as a fraction would be b minus x over 1, right? So let's just write over 1 there. So we're going to multiply, we're going to flip it, right? Because we're multiplying. So it's going to be 1 over b minus x. Okay? So now we're going to have x minus b over x plus 1, b plus 1, and b minus x now added to the denominator, right? Because we're multiplying the denominators and the multiples and the numerators essentially when we're multiplying the fractions. So now we're almost done yet, because notice something interesting. We have x minus b and b minus x, and while they may not look identical, we can actually write one of them in terms of the other. Okay, so let's see. So how can we express x minus b in terms of b minus x? Well, we can notice that here the x is positive and the b here has a negative sign, but in the denominator it's the other way around. So that means we can actually introduce a negative sign, have parentheses, and write b minus x. Because you notice that if we flip x minus b to write it as b minus x, we have to have a negative sign in order for it to satisfy the condition that x is positive here, positive coefficient, which two negatives gives you a positive, and then the negative coefficient in front of b, which is also satisfied by this negative sign outside the parentheses. So now we're ready to copy down the denominator. So we're going to have And now notice that it looks more similar, right? Because b minus x divided by b minus x, we can let it go. And this will give us 1, but there's a minus sign, so we have a negative result, negative 1 over x plus 1, b plus 1. And that's it, right? Because b minus x is gone. So this is your final result. You have worked from this mess, you have worked all the way to this result. Good. I'll see you in my next video. We're going to talk about another example of a complex fraction.